Okay, so if you've ever tried to build a serious AI model on your laptop, you've probably hit that wall. You know the one. It works, sure, but it's slow. To make it truly powerful, you've got to go bigger. Today, we're going to dig into exactly how you can scale your work from just one machine to a massive, powerful cluster. And really, this is the million-dollar question, isn't it? You've poured all this time into getting your Python code just right on your laptop. So how do you unleash it on, say, 1,000 machines without having to do a complete soul-crushing rewrite? That's the puzzle we're solving. And let's be real, this is a huge challenge. Moving from one machine to many isn't just about adding more power. It's a whole new world of complexity. All of a sudden, you're trying to juggle network communication, fault tolerance, and coordinating everything. It is, without a doubt, one of the biggest headaches for developers in AI today. But what if there was a framework designed to handle all that messy, distributed computing stuff for you? Well, this is where our first key player comes into the picture, a project called Ray. So, what is Ray? It's an open source framework built to solve this exact problem. Its whole mission is to give you a simple Python native way to build apps that can scale from your laptop all the way up to a huge cluster. The keywords here are simple and universal API. The idea is you don't have to learn a dozen new complicated tools. Probably the best way to think about Ray is as a high-performance engine for distributed computing. It's the powerful machinery running under the hood that takes your normal Python functions and classes and gives them the superpower to run in parallel across tons of different machines. But Ray isn't just an engine. It's more like a full toolkit. It comes with a whole suite of specialized libraries that cover the entire machine learning pipeline. You've got Ray Data for wrangling massive data sets, Ray Train for distributed training, RayServe for getting your models into production. It's a completely unified, really powerful ecosystem. Okay, so Ray is our high-performance engine. But where do you actually run an engine like this in a real-world production environment? For pretty much everyone these days, the answer is Kubernetes. Yup, Kubernetes has basically become the operating system for the cloud. It's the standard for managing applications in containers, and it handles everything: deployment, scaling, even healing apps when they break. So it's kind of a no-brainer. If we want our Ray applications to be robust and production-ready, we've got to run them on Kubernetes. And this leads us to the next critical question. If Ray is the engine and Kubernetes is the vehicle, how do we actually connect them? How do we get these two super powerful systems to talk to each other without a mountain of custom scripts and configuration nightmares? Well, the answer, and the second star of our show today, is a project called KubeRay. KubeRay is the official purpose-built bridge between the world of Ray and the world of Kubernetes. It's what's known as a Kubernetes operator. And the easiest way to think of an operator is like a specialized robot that you install inside Kubernetes. Its only job is to teach Kubernetes the language of Ray so we can manage Ray applications just as easily as it manages any other workload. So how does it do this? It works using something called Custom Resource Definitions, or CRDs. Now that sounds complicated, but it's just a way of saying KubeRay adds new vocabulary to Kubernetes. All of a sudden, Kubernetes understands new concepts like a RayCluster or a RayJob. And this is huge because it means you can manage a complex Ray cluster using the same simple kubectl commands you already know and use for everything else. So what can we actually do with this new vocabulary that KubeRay gives us? Let's break down the 3 core components it introduces. First up is the Ray cluster. This is the absolute foundation. You just define what you want. Let's say a head node and 10 worker nodes in a simple configuration file. KubeRay takes that file and does, well, everything else. It creates the cluster, it automatically adds or removes nodes based on the workload, and it even replaces failed nodes for you. It's complete automated lifecycle management. Next, we have RayJob. This is absolutely perfect for tasks that have a start and an end, like running a nightly data processing script or training a model. Instead of keeping a cluster running 24/7, a RayJob spins one up on demand, runs your script, and then, and this is the best part, it tears everything down automatically when it's done. So you only pay for the compute you actually use. It's incredibly efficient. And you can see just how beautifully automated this whole RayJob lifecycle is. You submit your job once, and KubeRay orchestrates this entire 4-step process behind the scenes. You never have to think about provisioning or deprovisioning the infrastructure again. It is all handled for you. And finally, we have RayService. This is your go-to for production model serving. The applications that have to be running all the time. It combines a long-running RayCluster with RayServe. And get this, it's built from the ground up for high availability. So if a node fails, it gets replaced. Plus, it enables zero-downtime upgrades, so you can roll out a new model version without your users ever noticing a thing. So to put it really simply, if your task has a clear start and finish, like a training run, you're going to use a RayJob. But if you're building an always-on application like a real-time prediction API, you're going to need a RayService. It's all about choosing the right tool for the job. Okay, so when you put all of these pieces together, what does it all mean for the future of building large-scale AI? I think the key takeaway is this. KubeRay provides that absolutely essential bridge between Ray's simple, powerful scaling for developers and Kubernetes' robust, industry-standard orchestration for operations teams. It creates a perfect separation of concerns. Developers can just focus on writing Python, and platform engineers can manage it all with the cloud-native tools they already know and love. This quote from the official documentation really captures the mission perfectly. The whole goal of KubeRay is simplification. It's designed to take on this immense underlying complexity so that building scalable AI becomes more accessible to way more developers than ever before. And that leaves us with one final big picture question to think about. As these AI models just keep getting bigger and more complex, are these kinds of tightly integrated, unified frameworks the only realistic path forward? The combination of Ray and KubeRay makes a really powerful case that the answer might just be yes, definitely something to chew on.